Hello everyone, and this is my small task about how to I play with audio files. The task was the following: I have I have the data set of the audio files, and all these audio files was separated for the two big classes for the braking and the accelerating, and inside these two big classes it exists four small subclasses with let's say the different kind of the tram, and I try to find the best features from the audio uh, which I can use and clearly distinguished with which audio to belong for what subclass among the accelerating. And this small work I just use only the accelerating class, and I play with data only with accelerating class and the subclass. So I import all the necessary dependencies. I just upload the audio file, and I play it with Librosa. Then I try to just plot the audio file to find what it is. Maybe I can find any good patterns. So unfortunately, all most of the audio file was just standard way. So then I try to examine some of the features which I can grab or do. So I create the sample spectrogram, and I just realized then if it is the accelerating class, the uh, all accelerating audio files have the pitching sounds which is increased, and you see this small line over the over the 2000s. So and okay, this is one what I can find while I use the sample spectrogram. Then I create the spectrogram with log frequency axis with log normalization, and I found that these features of the increasing the audio pitch is more clearly visible of the accelerating sounds. Then I create the male spectrograms, and if we compare the log axis spectrogram and the male spectrograms, on the log axis these features is more and more clearly visible of the increasing pitch of the accelerating file, of the accelerating tram. Then I try to examine the crossing zero rate, and unfortunately it gives me nothing, because more or less this crossing rate is kind of look similar among all of the subclasses. Then I plot the spectral centroid, and it don't give me any good idea how to separate four subclasses. And also I plot the spectral roll-off and MFCC feature, and all this, and also I plot the chroma frequencies to find on based on what features I can clearly divide all these subclasses. And also I create the energy, and maybe on energy, as you see during the acceleration, energy is increased. It is one of the big conclusion what I find. All the accelerating file increase the energy from the from start to beginning to the end, and you see from the start it's a little small, and then and it's bigger and bigger. And then I find the duration of the audio file, and I try to find which is which is duration of my audio file, and I found it was about three from 3 to 4 seconds. Then I use the library of the it's called pyAudioAnalysis, and this library can extract a lot of the features from your audio file really fast, and from my file it's just of the lightning speed create me 68 features of from one audio file. You see, it was really good. And then I just to normalize this feature and try to create the plot, and unfortunately it don't give me any good patterns. So then I do the following. I just take all these 68 features and create the feature vector of the my wave file, and so for the later work I just from each audio file I create a feature vector of the 68 dimension and try to find which features is best for the subclass separating. And as I told you previously, inside the accelerating class I have four subclasses. It's one, it's a new tram, two, it's long tram, just long, it's not new, it's standard. The third one is a short version, and the fourth class it's really old. Then I created the bunch of the helper function. I just to take the path of the audio file, take this audio file to do all this stuff, to extract the features, to create the data frame, and all I do with the help of this helper function. Then I try to find does my four classes is balanced or not, and I found that all these four classes is extremely unbalanced, because you see on the first class I have around 500 examples, and of the third class I have only 64 examples, and you see this class is extremely unbalanced. Uh, so I do the same for the breaking class, but I don't use the breaking sounds later. It's just for the testing hypothesis. Does the class 3 is extremely low of the examples, and it was. So then I try to find the plot distribution of the audio file lengths, and I found that more most of the audio files have lengths between 3 and 4 seconds, and you see the distribution it's skewed to the left side, and it is and distribution close to normal Gaussian, but it's really skewed. Maybe I have to create the KDE plot, but it was just enough for me for the judgment. So as you see, all of the four classes have between 3 and 4 seconds duration. Then I do the following. I just create the huge data frame for the all four subclasses. This data frame for the class 1, class 2, and class 3, and find to describe, and but unfortunately it's too many features which I and my task was the following: to find the best one for the clearly class dividing. Uh, I mean the subclass. Uh, then my idea was the following: I tried to eliminate and maybe drop some of the features with a highly correlated. I create the correlation plot, and I try to make the threshold of the correlation more than 0.7, and I create the correlation plot maybe with the idea to find any useless features, but unfortunately among all these four classes I can clearly find the the clear pattern which features is correlated. Of the most maybe of the top left corner, it's a correlated feature, but unfortunately pattern on the for all classes is not really clearly, so I so it was not good idea. So then I create the, let's say, the united data frame. It was the more than 1,000 examples. I just to concatenate all these four subclasses among to one huge data frame. And then I do the following. I also create the same library, pyAudioAnalysis, but without my helper function. And this, as you see, using by about, let's say, 2 or 3 lines of code without any huge helper function. It's really fast to extract the feature from your audio file, but as you remember, the previously it was only the 68 features, and now I extract more features. It was about just me just yeah, and that time it about 100, it was twice more. It was 140, because the previously it was only mean feature, only mean value of the feature, and at that time it was increased twice because it is also standard deviation features of the all audio files. So from the later analyze, I will use the 140 dimension feature vector extracted from the all audio files. My idea was the following: maybe not only mean features is meaningful, maybe also STD feature is meaningful, and I will explain you later which conclusion I will have. So then I create the data frame of the all subclasses, and I also create the correlation plots to find maybe. And you see then the standard deviation is mean it's uh, clearly correlated, you see. And but unfortunately on the different subclasses the correlation was a little bit difference, so that's why I don't use the correlation matrix to eliminate some of my feature, but I try to find it, and I try to plot and visualize my data and find that with the additional standard deviation, some of the standard deviation and the mean features is highly correlated, but uh, it's not good enough for eliminating some of the feature. So then I do the following. I create the huge data frame again, but that time it was a lot of the features, as you see. So then I try to again to find which does my class balanced or not, and if as you see on my bar chart, the class 1 and 4 have a lot of example, and class 3 have the least one, so it's been clearly that class is unbalanced. Then I try to plot the correlation heat map, maybe to find which class is correlated with a high correlation, and my correlation threshold was really high. It was about yeah. So I try to find only 10 most meaningful features with with a big correlation, but unfortunately it gives me again nothing. So it was unfortunately it was a dead end. Then I tried to find the following. I tried to find so this based on this heat map. I found that the features chroma 11 and MFCC8 is correlate uh, between each other, and I try to find is it really or is it not, because I can of the high correlation I can eliminate it, but as you see of the pair plot, it's so the dependencies one features of the another is not so, it's not so good for the linear correlation. Maybe the and again the distribution close to to normal and again skewed to the left, but it's not good enough, unfortunately. Then I try to find if I can find any feature with good distribution with 4 peaks, and maybe based on this only 1 or 2 features I can clearly divide on my class, and you see it's not so good again. You see most of the features have the Gaussian not most, some of the features have the good distribution, but again I can't find good feature for the splitting by this way. So what I can do next, I just to plot the box plot to find maybe I find any good or meaningful feature for the clearly dividing, and you see I tried you see that's maybe MFCC 3 mean it's good enough because it's clearly it's not, it is the crossing each other, but not so many if we compare to with let's say the energy mean, you see. So and then I try to find can I use the parallel coordinates. So the idea of the parallel coordinates graphs, it is clearly show me on the plot which feature can divide all my 4 subclasses, and based on the parallel coordinates and also on the box plot, I found some of the features, but unfortunately it is not the 4 features. I found some of the feature, I mean not for because I can't find any good feature which can divide all these 4 classes. I I can find feature which can clearly divide only 3 classes. And you see, for example, I explain you my idea. As you see, MFCC6 mean clearly divide the class number 1. It's clearly see blue, class number 4 and class number 2, and it is unfortunately not divide the class number 3 because the green one it's not here, and maybe because the class number 3 it's have not so many features. And if we see of the MFCC 10, it is clearly divided class number 4, 3 and 1. And the class number 3 again, it is not clearly visible maybe, and I suppose that is because we don't have any so many examples of the class 3. So, and you see it is just bunch of some lines without clearly class separating. So based on this graph, I find some of the features, and I eliminate 100 about 140 features to just to the 21 features, and I try to check my hypothesis, is it true or not. If I can, based only on the 21 features, can clearly divide 4 subclasses. And I try to use just the logistic regression, uh, just a simple model for the class dividing, and you see I found the and I get the about the accuracy more than 90%, and I plot the confusion matrix. It's and I found it is more or less uh, good enough, maybe. Then my idea was the following: can I eliminate and use for the class dividing only one features? And I found that the MFCC 10 mean have the 72% of the total. It is the totally correlated of the class of of the class number. And I try to find again the logistic regression. From the first look, the accuracy was about the 71%, and but as you see after the looking on confusion matrix, it is not even to find the class number 2 and class number 3. So this one features it's not good enough, and every time you have to use the confusion matrix to find which class is best node. So then I try to use the variance threshold to find which features is best or not. And yeah, and it again, if I correctly remember, give me nothing. Then I try to try to trying to find the following: can I eliminate the standard deviation features or not? Because among of these 21 features, as you see, a lot of the standard deviation and a lot of mean features. So I just take only the mean features, and it is about half. So finally I take just the 11 features, and I use these 11 features, and again I have the 92% of the accuracy, and even the confusion matrix give me the not so bad result as I can imagine. So as you see, only the 11 features we can use to divide all these subclass. So, and I also the calculate precision recall and the F1 score, and you see all the class. It's and again the class number 3 give us the worst result because the mm, the class number 3 don't have a lot of features. We have only less than 80 examples. And I try to find does the standard deviation features give us any meaningful, and I just to take only standard deviation features, and it gives me the very weak accuracy, and you see it is not give us any good result, especially for the class number 2 and 3. So we can read the standard deviation function. And finally, we just take this 11 functions of the mean and create the pair plot and find which one is best, and then I try to eliminate even less of these 11 features, and I try to create the pair plot of these 11 features and try to find which can I use even less features for the subclass finding, and I found that I can use only some of them. So, and I plot the violin plot, and the violin plot show us that unfortunately not any features can strictly divide all these four subclass. So that's all. Thank you very much, and so this is my conclusion, and for the best we can do of course more, and this notebook have to be endless, but thank you very much for looking, and see you soon with my next work. Bye.